Hi, this is Richard C. I'm a math tutor at Wyzant, answering a question submitted by a student. And I started working on this and got interrupted. So let me start over here. So this is a calculus student who's studying the Rolle's theorem. And he wants to use Rolle's theorem to find either a relative minimum or a relative maximum in this function. The first thing to do, I think, is to rewrite the function so it's more recognizable. And this is clearly a parabola opening up. We know it opens up because the leading coefficient is positive. We can find the vertex of the parabola by using this formula, negative b over 2a. We find the x-coordinate of the vertex is at 3. So this means the parabola has a axis of symmetry at 3. And when you plug 3 into the function, f of 3 is going to be equal to negative 35. So, it's a parabola, opens up. Okay. And because it's a polynomial, we know that it's continuous on this function. It's actually the domain for this function is all real numbers. The range for this function would be from negative 35 on up. And so there are no issues here about continuity. So we are satisfying, this function satisfies the prerequisites. It has to be continuous on 2, 4. So, and that's true because it's a polynomial. It's a parabola opening up. And then it has to be differentiable on 2, 4, but it's the we're excluding 2 and 4, the values themselves. So let's take a look at that next point. Let's find the derivative. Let's change color here. So f prime of x. So we're just using power rule here. So it's 8x minus 24. And that's a line. So obviously the derivative, which is the equation of a line, exists. There's no holes or jumps or anything in the derivative. So it's differentiable on 2, 4. It's differentiable on all real numbers. So we've satisfied that. We've satisfied the two conditions for Rolle's theorem. And so now we are able to say that and if f of a is equal to f of b, so I need that third one. So let me change colors again. F of a equals f of b. So let's do that in another color. So f of a, f of 2, when you plug that in, so it's going to be 4 times 4 minus 24 times 2 plus 1. That's negative 31. And then f of 4 is going to be 4 times 16 minus 24 times 4 plus 1. And that's going to be negative 31. So now we've got all three of these things checked. And now we need to just find the relative minimum, which is clearly the vertex. Now, if we want to use calculus to do it, we would just set f prime of x to 0. So let me just change colors one more time. Set that to 0. So 8x equals 24. So x is equal to 3, which is clearly the value of c. So this is c here. I'm just referencing the c here. So c is 3. So that's it. Yeah, it's not a difficult theorem, and you might kind of wonder why we need it based on this. It's actually used later in calculus and in certain situations. It comes in handy, but basically it is telling you that if you have a function that's continuous and differentiable, and if you can find 2 points on the curve that have the same y value, then in between those 2 points there has to be, so in our case it was 2 and 4, so 2 here, 2, let's say 2 is there, and 4 here's negative 31. So what we were working with here, 31. And so this intersects at 2, this intersects at 4. So there are two numbers, two x values, for which the function has the same y value, in this case negative 31. And somewhere between those two values, there's an x value where the curve finds a relative minimum or a relative maximum. So it's actually, in this case, it's pretty simple, but it can be helpful in more complicated situations. Okay, so that's it for Rolle's theorem. I'll see you again next time. Bye-bye.